In this video, we're going to explore computing the derivative at a point and computing the derivative of a function. Now, computing the derivative at a point, what we do is we have the, the derivative of f of x at a is the limit as h approaches 0 of f of a plus h minus f of a over h, which is equal to the limit as x2 approaches a of f of x minus f of a over x2 minus a. Okay. You can use either definition works when we're asking for you to compute the derivative at a point A. If we ask for the instantaneous rate of change, you need to use the limit as x2 approaches x1 of f of x2 minus f of x1 over x2 minus x1, as that is the definition for the instantaneous rate of change. But for the derivative, we can use either of these definitions. Now, if I'm going to compute the derivative at 2, this is the limit, and I like to choose this definition. So everything we're going to go for will be using this definition. So the derivative at 2 equals the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h, which equals the limit as h approaches 0 of 2 plus h squared minus 2 squared all over h. This is equal to the limit as h approaches 0 of 2 squared plus 2h plus h squared minus 2 squared all over h. Here the 2's cancel, giving me the limit as h approaches 0 of 2h plus h squared over h. I can split this fraction to give me the limit as h approaches 0, 2h over h plus h squared, where h, simplifying this down, gives me the limit as h approaches 0 of 2 plus h, which is 2 plus 0, which equals 2. We have our derivative. Notice that once I get to this point, it is purely a limit question. Okay? When you're computing the derivative, when you're computing the instantaneous rate of change, using the limit definition, step 1, set up limit. Step 2, compute limit. This setup is new. This is new. This is old. We've been doing this for a while. We've been computing these limits. So in each of these cases, it's just set up the limit and then compute it. Now, our second limit, the derivative of f of x equals bx at 0. F prime of 0 equals the limit as h approaches 0 of f of 0 plus h minus f of 0 all over h, which equals the limit as h approaches 0 of b to the 0 plus h minus b to the 0 all over h. Now this equals the limit as h approaches 0 of b to the h minus 1, because b to the 0 is just going to be 1, all over h. Now, we don't know what this is in general. In fact, this is a really annoying limit in general. However, E is the number that makes this limit equal to 0. It is the beautiful number. It's the perfect number. It's the number that makes this 0. Because this limit is 0, we can compute the derivative of e to the x at 0. We know e to the x, but b to the x, we don't know what that limit's going to be. At this point, we're still a little bit confused. Okay, so we'll learn more about how to do that shortly, but I just wanted to mention that the one that we know how to do is e. That is what we know how to do, e to the x. Now we transition to the derivative of a function. Now with the derivative of a function, what we're going to do is we're going to leave this x here and treat it just as a variable. It's just some constant, it's some number. We're just going to leave it alone. But we're going to do the exact same thing that we did before. The same definition, the same expression, except for instead of putting a number in for x, we're just going to leave that x alone. So if we compute the derivative of the function f of x, this is the derivative of f of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, which in this case is the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Now here, this to me looks like a difference of squares. X plus h plus root x over root x plus h plus root x. Using my difference of squares formula, I get the limit as h approaches 0 of the root x plus h squared minus root x squared all over h times root x plus h plus root x. Well, this equals the limit as h approaches 0 of x plus h minus x all over h root x plus h plus root x. Well, this is equal to the limit as h approaches 0 of h over h root x plus h plus root x, which equals the limit as h approaches 0 of 1 over root x plus h plus root x. Now I'm able to plug in h equaling 0. So the square root of x plus 0 plus root x, which equals 1 over 2 root x. Again, we have two steps. Step 1, set up limit. Step 2, solve. Okay. Now, the solving of this limit is very similar to what we did before. We rationalize it. Okay. The setting up the limit is the new part. And on your quiz next week, something similar to these two expressions will be given to you. You're going to be asked to compute the definition of the derivative using the limit definition. But we're not going to give you the limit definition. So you need to memorize this. Okay. It should be memorized. Now, let's take a look at our second example, example B. So we're looking at f prime of x, where f of x equals 1 over x. So this is the limit f prime of x is equal to the limit as h approaches 0 f of x plus h minus f of x all over h. So this equals the limit as h approaches 0 of, my function is 1 over x plus h, because I'm replacing my x with x plus h, minus 1 over x, all divided by h. Now here, this looks confusing to me, but instead I can write it as the limit as h approaches 0 of, and I'm going to do a trick I did before, 1 over x plus h minus 1 over x times 1 over h. In fact, this is why I went through these type of questions. It's because we have to rationalize. We have to split this up and then create a single fraction here. Well, this equals the limit as h approaches 0 of 1 over x plus h times x over x minus 1 over x times x plus h over x plus h, all times 1 over h. This equals the limit as h approaches 0 of, and I get a common denominator of x times x plus h. And in the numerator, I get x minus h times 1 over h. Now this equals the limit as h approaches 0 of minus h over x plus h, which equals the limit as h approaches 0 of minus 1 over x plus h. I'm now able to plug in 0 for h. So I get minus 1 over x times x plus 0, which equals minus 1 over x squared. And this is my derivative. Again, step 1, set up limit. Step 2, solve limit. Okay. When we're in terms of the quiz next week, this is the end of the quiz. Page 54 is the end of the quiz for quiz 2. And to review these types of questions, I encourage you to look at chapter 1.1 questions 3 through 18.